The object of this video is to demonstrate the box model, and I will do so by illustrating one long problem. This is a circuit we've seen before. Notice that the beta is equal to 100. So let's begin by finding voltage on the base by saying it's 15 volts times 330 ohms divided by 1.5 kilo ohms plus 330 ohms, that equals 2.7 volts. Let's go on by saying that voltage on the emitter is 2.7 volts minus zero point 0.7 volts, which equals 2 volts, and that current through the emitter is approximately equal to the current through the collector, and that's 2 volts divided by 470 ohms, and that equals 4.26 milliamps. And then R prime BE is 25 millivolts divided by 4.26 milliamps, and that equals 5.87 ohms. When the signal is coming into the transistor, it sees R prime BE, but this R prime BE is magnified by beta. So in this case, it would be 200 times 5.87 ohms, that equals 1.1 kilo ohms. And this is called impedance of the base, Z base, although some books, and even this book in some chapters, calls it resistance of the base. But we will call it Z base. The signal also sees resistance equivalent, which is R1 in parallel with R2. In this case, if we do that calculation, we find that it's 270 ohms. The result of this calculation is that now we have R equivalent, 270 ohms, in parallel with Z base, which is 1.1 kilo ohms. We now have R equivalent in parallel with Z base, and we're going to call this Z in, input impedance, Z in. We calculate input impedance by saying 270 ohms times 1.1 kilo ohm divided by 270 ohms plus 1.1 kilo ohm, that equals 216 ohms. So what we have done is we have simplified the input side of the transistor circuit into the signal generator with the signal coming in, the capacitor that was at the input, and input impedance of 216 ohms. On the output side, if we were at V out looking back into the transistor, we would see a current source, which is really collector current, in parallel with RC collector resistance and the resistance of the load. In this case, it's 1.2 kilo ohms in parallel with 6.8 kilo ohms. We calculate output impedance, or Z out, by saying it's 1.2 kilo ohms times 6.8 kilo ohms divided by 1.2 kilo ohms plus 6.8 kilo ohms. That equals approximately 1 kilo ohm. If we put all the parts together, now we have taken our transistor circuit and we have simplified it so that we have a signal coming in through the capacitor into the input impedance, and then we have a current source, and then an output capacitor and a signal coming out, and also an output impedance. And now this is called a box model, and this will be used for further calculations, but we'll leave that for a later date.